Hello, my name is Raj Narigotu. So I'll be presenting my project. The title is Comparative Analysis of Random Forest, XGBoost, and LSTM for Crop Yield Prediction in India. So this is part of the Machine Learning CA2 project. So problem statement and motivation. So crop yield prediction is very important in agriculture, especially when it comes to countries like India. So it helps farmers to plan better and reduce risks and improve the food production as well. So traditional methods like linear regression have been used, but so usually they cannot handle changing weather and different farming conditions as much. So to solve this problem, I decided to use machine learning and deep learning models to predict crop yields and so that we can compare their performances. So coming to data sets which has been used in this, I used three data sets for this project. The first data set has crop production details like from 1997 to 2020. So this includes area, fertilizer, pesticide, and yield information. So the second data set contains rainfall data from 1901 to 2015 for different regions in India. So the third data set, it has national average temperatures from 1907 to 2020. So there was some challenges with these data sets, like matching regions from rainfall data to crop data, and also missing soil information data set. And so when it comes to temperature, we don't have state-wise temperatures. So, however, I tried handling these challenges carefully in the pre-processing stage. So moving to methods and pre-processing information. I selected key features like rainfall, temperature, fertilizer, and pesticide. Categorical features like crop, state, and seasons, those were label encoded. And I split the data into 70% for training, 15% for validation, and 15% for test. So, and for modeling, I chose Random Forest, XGBoost, and LSTM models. Each model was trained and then evaluated separately so that we can compare their results. So, and coming to model implementation, for Random Forest, I used 100 trees with the default settings. For XGBoost, we have 100 estimators and a learning rate of zero point 0.1 and also a maximum depth of 6. And when it comes to LSTM, I created a sequence model where 9 years of features were used so that we can predict the 10th year's yield. In the beginning, at first, I trained the LSTM model using only the rainfall and temperature, but the results were not that good. So after I added the fertilizer and pesticide features and normalizing the features, LSTM model's performance improved a lot. It's better after that. And then moving to the results and model comparison. So these are the results which we got. Random Forest achieved RMSE score of 178.73 and R square of 0.9606. And XGBoost, it actually performed better with the RMSE score of 158.24 and R square of 0.9691. And when it comes to the improved LSTM model, which we had, has a score of RMS score of 0.31 and R square score of 0.0367. This is after scaling. So the results showed that XGBoost performed well comparatively. And to be honest, XGBoost and Random Forest, both of them performed well. But so LSTM improved a lot after adding features. and it actually needs more longer sequences to give better results. And these are some of the plots which we have in our code. And then moving to error analysis and insights. In the beginning, the LSTM model, as I mentioned, it did not perform well because it had very limited input features, and the sequences were short. And after I added more features and normalized the data, the LSTM model improved a lot. But still, it's not that better. It could not beat the tree-based models. So Random Forest and XGBoost were able to handle the noise, and also they were able to handle incomplete data in a better manner. So one of the challenges was that I did not have a soil data set because it was not available, and even though if it is available, it was a paid subscription, and I only had national average temperatures, not the state-wise temperatures. So these could have affected the model performance. That could be one of the reason. And to conclude this, random forest and XGBoost models were highly effective to predict the crop yields using structured data sets. So LSTM showed promise, but it needs a lot of larger data sets with more features to actually reach its potential, is what I feel. In the future, I plan to improve these models by adding soil data and state-wise temperature data, and also using longer historical records so that they would perform better. So exploring advanced deep learning models like transformers could also help in the future research. So yeah, this is pretty much everything. Thank you so much for your time. You have a good day.